Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, how to use it in Eclipse IDE. So in the previous lecture, we discussed several steps that we need to take in Eclipse IDE to be able to correctly set up JNI, set up a C project, Java project, create the header file, and then add it to the C project, compile the C project, get the dynamic library, and then add it to the Java library.path, and then being able to call and execute native methods. So unlike NetBeans IDE, which we already looked at, and it was very automated, it was a very automated process. We need to do a lot of manual configuration in Eclipse IDE to be able to do this mixed development between Java and C++. And the step one was to install the C++ development toolkit plugin, CDT plugin from Eclipse Marketplace. Step two was to create a Java project and add the native methods to the Java classes that we want to basically delegate to the C++ methods, and configure the external tools. And this was one of the important steps, because we need to create the header file, and in order to use the header file, or in order to generate the header file from a Java class, we need to get the class file or .class file and then run the java -JNI on that class file. And in order to do that, we have to set the working directory to the bin folder of the Eclipse project, because that's the top level project. And then we write java -JNI space the class name, which is the fully qualified name, package name.class name. Okay, and then we run the java -JNI on the current class that contains the native methods, and it generates the header file. And then we create the C++ project and copy the header file to the source folder, and then create the .cpp and include that header file into the .cpp file, and then add the body or implementation of the methods that we want to use the JNI bridge to call them. And then however, in order to be able to compile, we have to include the JNI.h in our header file. And in order for the compiler to know where the JNI.h is, we have to go to, point the compiler the include paths, right? The compiler has an include paths. These are the folders that the compiler by default search into them. And then add the JDK folder has a folder called include, and the include has the JNI file. So we have to add the include folder of the JDK to the compiler include paths. All right. And then once we do all of these steps, we are ready to compile. And in order to do that, we have to set the target artifact of the project to dynamic library. Not, for example, we shouldn't set it to an executable, because we want to create a dynamic library. And we have to make sure that we set it to dynamic library, not a static library, because Java cannot load a static library. In Java, we only can load dynamic libraries. And then we compile the C++ project and generate the dynamic library, and the rest is very easy. We already have looked at these. So in the VM argument of the Java class that we want to run, we set the -d java.library.path to the folder that contains this dynamic library that we generated. Now actually this is the standard way, but in Eclipse there is a better way of pointing the Java to where the dynamic library is, and I'll show you in a few seconds. Finally, step 11, the last step is to use a static initializer, because once we generate a dynamic library and tell Java where the library is, then we have to also tell Java when to load it into the memory. Because not only Java needs to know where to find the library, it also needs to know when to load it into the memory. And typically we want to load the static library into the memory exactly when the class is loaded into the memory. So that's why we use a static initializer to and call the system.load library. Okay. Now we discussed the external tool for Java in Eclipse IDE, and this is a very important thing to understand. So we come, so the external tool in Java has this run button with this suitcase, and we come here, and then click on this new, and we create a new external tool. I just called it here Java Edge, and then the location is the binary file for the Java Edge, and it's so you click on this browse file system, and then go to where your JDK is, and then go to contents /home/bin to the binary folder of your JDK, and then Java Edge. Okay, so this is the binary location of the binary file for your or the executable file for your external tool, Java Edge. Okay, and then the working directory, we said that Java Edge needs to get a class file, .class file, as an argument. So we set the working directory to workspace location :/native/bin. So it's the bin folder of our Java project. Note that it's not the source folder, it's the bin folder. And then in the arguments, we add the -JNI. We have to make sure to add this -JNI, so it knows to create the header file. And then we have to give the fully qualified name of the Java class, which is the package name .class name. And in order to make this as a template, so it can work on any basically class file in our project, I use one of these variables that are available inside the Eclipse. These are the environment variables: $curly brackets Java _type _name. So this gets the fully qualified name of the basically Java file. Okay, so we can select this from this variable, or you can just type it. And then when we select the Java file and hit run, it executes this command Java Edge -JNI and this fully qualified name, and then it generates the header file and puts it in the bin directory. Okay, so let's head to Eclipse and continue with the last example. So in the last example, I created this native project and then created this test native. It has one native method, which is multiply. It's not a static, so it's a instance method. Takes two double, multiply them. It's supposed to multiply and return a double. And here I'm creating the main method. I'm creating an instance of this class, and then call the multiply, and then print the result. So if I run this at the moment, it let me just I think I added this VM argument in the run arguments, so these were both, so we don't need these. At the moment it throws this runtime exception, unsatisfied link error, because we have not created the dynamic library and we haven't told Java when to load into memory. So this test native is my this test native is my C project, and it has an include folder, and in the include folder you see I already have this JDK contents home include, JDK contents home include Darwin, and this Darwin is the folder that has the machine dependent JNI file. Okay, and to recap, in order to add these JDK folders to the compiler include path, I went to the properties and the C++ build, and I went to settings, tool settings, and in the tool settings you can set this for each older configuration or for your target configuration, debug or release. Right now I'm compiling in the debug mode, and I went to the GCC C++ compiler. In the includes, in the include paths, you add both the include and include /Darwin. Okay, so this adds the JNI.h, this one adds the JNI_MD.h, machine dependent. Okay, and then now that I have these, so basically here we run the external tool, and then it generates the header file. I copied the header file here in my C project, C++ project, and then in the C++ file I added the body. Note that we don't need this IO stream. We have to include the header file for our method test package underscore class dot h file, and then we just add a simple implementation for the method, which is param1 times param2. Okay, and now the last thing is we have to make sure that we tell the compiler to generate the dynamic library. So here again in the C++ build, in the settings, in the C++ compiler, we already have this. So in these tabs we have this build artifact. Okay, now we tell it instead of telling it to create a executable, which is by default is executable, we have to tell it to create the artifact is a shared library. Okay, and it automatically adds the extension dylib and output prefix lib. All right, so keep it as is. So make sure the extension is dylib, we don't have any other option, and the output prefix is lib. I believe we can set it to SO, but let's just keep it as dylib, which is the standard for the Mac OS, and the prefix is lib. All right, so make sure that in the build artifact, the artifact type is a shared library, and then apply. Okay, now we're ready to build. So you see this is the build, and if I build it, build finishes, we immediately have this debug folder, and this is our binary, which is a dylib. It's also has this nice view, binary view, which has our dynamic library, which is just C++. Okay, and it has the header and the method. So our dynamic library is created. Now what we can do is copy this and go to our Java project. So I'm going back to the Java perspective, and let's close this, going back to our Java project here. And what I'm going to do, I'm going to create a folder in this project and call it let's say JNI folder. Okay, and then I'm going to paste the dynamic library here. So now I have a dynamic library in the project, and what we need to do now is to add it to the java.library.path. So let's right click on this dynamic library, get the absolute path to the folder. We don't need to name, we need only the path to the folder. Okay, and then go to the basically go to the run configuration. I'm running this test native with this test native one. So basically let's go to run configuration, test native one. In the arguments, I'm going to add -d Java. These are system the system parameters are identified by -d. Java.library.path equals and the path that we copied. So this is the path to the folder. Okay, so don't include the name of the file, and then apply, and then run. And we still get this unsatisfied link error. That's because we need to also tell Java to load it into memory, system.load library, and we drop the lib from the beginning and drop the extension. So eventually the name is test native. Okay, and let's run it one more time, and we get the result 2.42. So this is as you can see, developing a JNI in basically Eclipse has more work to do. It's more manual configuration, but Eclipse gives you more freedom to do whatever you want. Okay, now I mentioned that there is so right now the problem with this setup is that if I go to I added this VM argument to my run configuration, and this run configuration is just for running this class, right? So if I have multiple classes that have for example, let's create a new class. Let's test to native, and let's say this class also has a native method. So public double public native double sum double A double B. All right, now as you can see, if I want to run this, then I have to, when I run this, basically what happens is that Eclipse creates a new run configuration, and in this run configuration I have to go and manually add the VM argument again, -d java.library.path. okay, and this is a little bit tedious if we have a lot of files that have execution and we want to test all of them. So a better way in Eclipse is like this. So what I'm going to do, let's go to the run configuration, test native. Where is that test native? Test native 1, right? Yeah. So I'm going to remove this and then run this test native, and as expected we get this unsatisfied link error because it tries to load this in the memory but it cannot find it again. And so the better way is to right click on the Eclipse project and go to the build path, configure build path, and in the configured build path we go to the source tab and click on this source folder, and it has a native library location. Okay, and we edit it and select the workspace and select this JNI folder. So now the project for all the classes in this Java project, Eclipse automatically adds this folder basically to the -d java.library.path. So apply, okay. So this is one of the nice things about Eclipse. So you can say, okay, this project take this folder as the folder for the native libraries that I have for this project. And now if I run this, you see it works. Despite the fact that in the run configuration, this test native one, I didn't specify the VM argument, but it still works because Eclipse behind the scenes in the build configuration, it points the JNI, basically points the java.library.path automatically to this folder that we specify for the native library location. So I think it's always a better idea to use this approach and point the native library using this option. And okay, so now we created a new class in the same project. It has a native method, and I can in the main method I can create an instance of it, test new test2 native, and then double result is test.sum 1.1 2.2 and sysout result. Okay, now obviously if I run this, it throws the unsatisfied link error because we need to, let's also try to load it into the memory, system.load library, and we want to use the same dynamic library for all the native methods in all the classes in a project. So test_native, so we drop the lib from the beginning and extension dylib from the end. If I run this, so it knows where to find the native library, the dynamic library. It goes loads this, and still now it says unsatisfied link error. It cannot find this method sum in the dynamic library. So it can find it, it can load it, but it cannot find this method. So what we need to do, we need to select this, all right, and then run the external tool, this one that has a suite case here. And then what this does, this creates the header file. You see I'm going into navigator, test underscore test2 native, so package underscore class name, and this is the header file for this sum, again java underscore package name underscore class underscore method name. And then we copy this into our source folder. So copy this into our source folder, paste it there, and then I'm going to the C perspective, and here in the test native 2 we have this. So we just copy this and then we go into the C++ file, we add this, and then let's give the names. This object J double, let's call this param1, J double param2, and add the body. The body is just return param1 plus param2. All right, and now we need to also include the other header file, test native 2, test2 native. Okay, so all we need to do is to build this project again, and it creates a new binary. Now it has both methods, multiply and sum, for 2 different classes. Okay, and then we copy this into our JNI folder and replace it. Okay, and now if I go back to Java perspective and go into test2 native, which has this sum, this should work. Yes, 3.3. Okay, so I hope you understand the process. What we need to do, one of the main steps is to be able to configure this external tool to correctly run the Java Edge, to be able to create the header file, and then we need to also make sure that if I go back to the C perspective, we need to also make sure that the JDK include folders are in the include path of the C compiler, these 2 folders. So these 2 folders, because the include folder from the JDK has the JNI header, and then the include / whatever the name of the platform is, it has the machine dependent header files, and we already know that the JNI.h includes or calls or imports this JNI machine dependent. So it's very important to add both these 2 folders to the include path. Okay, and once we do that, we just simply compile and then create the dynamic library. So we have to make sure that the compiler is also set to create a dynamic library as the artifact of the compilation. And once we do that, we just point the project, C projects, the Java project to whatever folder the dynamic library is. And the best way to do it in Eclipse is to go to the basically in the project package explorer, right click, go to build path, configure build path in the source, add this native library location. Okay, it's much easier to do it this way instead of add the VM argument to each run configuration that you have, because multiple classes might have run configurations and then you have to manually set it each time, which is a little bit tedious. Okay, and then finally we have to make sure that we use a static initializer to load the library, and after that we are able to easily run and get the result that we want. Okay, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.